Our local group of galaxies is moving with a velocity of 631 kilometers per second with respect to the cosmic microwave background. The quest for the sources of that motion has dominated cosmography in recent decades, and it has been assumed that the excesses in the distribution of matter induce this motion. Here we trace the large-scale structure of the universe by the filaments and knots of the cosmic V-web. The motion vector of the local group is displayed as a yellow arrow. The scale of the volume under scrutiny exceeds 1.7 billion light-years. We've visualized the growth of streamlines of the large-scale velocity field. The structure of the flow exhibits a pattern of repulsion and attraction. Mass elements travel a typical distance of roughly 1,000 kilometers per second along flow lines. To further investigate the nature of the repulsion, we transition to the visualization of the antiflow, namely the negative of the flow. The antiflow converges on a location that we name the dipole repeller. For convenience, the region of the dipole repeller is materialized by a sphere of 5,000 kilometers per second diameter centered on the point of convergence. Now, we add streamlines of the flow seeded in the dipole repeller region. These streamlines converge on the Shapley attractor. Similarly, we restrict the seeding of the streamlines of the antiflow to the Shapley attractor region. The flow develops mainly in a plane containing the major overdensities, Perseus Pisces, Lepus, and Hercules. The antiflow develops in the orthogonal plane that corresponds roughly to the supergalactic equator. The antiflow lines travel through the underdensities lying beyond the Great Wall and Southern Wall on their way to the region of lowest density, the dipole repeller. The full extent of Laniakea, our home supercluster, is visualized. The dipole repeller is associated with a void reconstructed in the cosmic V-web. We rotate the view so as to align with the motion vector of the local group. This motion is aligned with the region of the dipole repeller. We now proceed to the view anti-aligned with the CMB arrow. The anti-alignment of the CMB arrow with the dipole repeller direction is stronger than its alignment with the Shapley attractor. The gravitational potential field is visualized by the means of three-dimensional surfaces of constant values. The surfaces of lowest potential materialize the dipole repeller. Surfaces of highest potential materialize the Shapley attractor. This visualization captures the structure of the flow emanating from the dipole repeller and falling on the Shapley attractor, and its complex interaction with the large-scale structure of the cosmic V-web.